Hi, welcome to our Matlab tutorial. Today's lesson is on curve fitting, where we will essentially model a set of data that was given to us, typically in XY Cartesian plane format. So curve fitting is essentially finding a function that can be best used to model a set of data. If you imagine a handful of scattered data points across a 2D chart, it's very common to be asked, how can you analyze this data? What is the trend telling us? Where is this data going if we were to try to predict? Or maybe there were two data points and we wanted to know what the rough estimate was at a value between those two data points. And one of the key functions we'll look at today is called polyfit. Polyfit takes in three inputs where x and y are of equal size and are typically scattered data. They might just be data on a plane. The third input, n, has to do with the method in which we want to analyze that data. So x is a vector with horizontal coordinates similar to like an independent variable, and y is the vertical coordinates or the dependent variable. And n is the degree of the polynomial. When we looked at the polyval, it was a method of evaluating a polynomial with known coefficients. Polyfit will give you an output of coefficients for a polynomial that, if were to be plotted over the xy data, would show you a general trend line of that data. So here's an example. We have a series of points. It looks like there's between, I don't know, 6 or 7 points. And we're asked to draw a curve or a straight line or any type of line in between these points to show exactly what this data is doing. So fitting with n equals 1 essentially means a straight linear line. So if we look at the data and we say here's the x coordinates, here are the y coordinates, and we want to use this polyfit. Well, the polyfit function does not create the line for you. It doesn't plot the line for you. What it does is it gives you the coefficients of a line that could be drawn perfectly through these data points. So because 1 means linear, a linear line can also be defined as y equals mx plus b. Well, you'll notice that y equals mx plus b is a polynomial, and the coefficients of this polynomial are m and b. So the output to the polyfit function, when using 1 as the order, will yield a 1 by 2 array, which are m and b. So now what we need to do is we need to evaluate the coefficients of this polynomial over a certain range. So even though we already have x and y defined, what we can then do is create a new range for x, which is essentially just the independent variable of where we want to evaluate the polynomial. We also learned in the last lesson on polynomials that we can use the polyval function to evaluate the coefficients over a certain range. So the first input to polyval will be p. Those are the coefficients of the line we'd like to create. And xp as the second input is the range that we'd like to evaluate it. It's pretty typical to make sure that the range of xp is in line with the range of the actual data points. So if you notice on line 1 where we define x, the smallest point is 0.9, the largest is 9.5. So it's very natural for us to set xp to that min and to that max. And we can use any increment that we want. In fact, if we wanted to enlarge this range to go a little bit further on either side, that's fine as well. So then what we can do is we can simply plot the xy data, and this third input here, the dash 0 dash or dash o dash, is telling MATLAB to plot these as just markers with no line. And then we'll plot xp and yp, the newly created data, on top of it. And we'll get something like this. So you can see the original data marking points with a straight line that we created. And you'll notice that the straight line goes from 0.9 all the way to 9.5. If we wanted to change the straight line to a higher order, imagine instead of y equals mx plus b as a straight line, we wanted a single curve. Well, now when we define that third input to polyfit as being n equals 2, we now get a 1 by 3 value for our polynomial. That's going to be an x squared, an x, and an x to the 0. And we could essentially add any value for n that we wanted, but only up to a certain point does it make sense. If you're wondering what that point is, it's typically the number of data points you have minus 1. So because we had 7 data points, the highest order that we would want to create a polyfit curve line in is going to be 7 minus 1, or 6. Let's do an example in Matlab. Let's create some random data points. We will say 3.2, 1.5, 4.6. Let me add a comma in here. You can say 4.9, 7.2, 11.5, 8.4, and 13.7. See how many data points that is. 1, 2, 3, 4, 7, 8, 9. 8 data points. And actually, I think I want to change this one to y. And we'll add x right above it. We can say this is minus 3.5, minus 2.1, minus 0.8, 1.2, 3.6, 5.0, 5.3, and one more we'll do 6.9. So we just created some very random data points. And if we decide that we're going to use our polyfit function, let's start with n equals 1. This should create a linear line for us. Now we want to create a range to evaluate. And typically we want to find the exact range that x is. Now it doesn't need to be exact, but if you'd like to, you can say we're going to start at the minimum value of x in increments of 0.1, and we'll end at the maximum value of x. Well, then we could define our actual line using the polyval function, where the first input is p. These are the coefficients that get outputted as a result of the polyfit function, and we want to evaluate it over xp. That's the new range that we created. Now, if we'd like to plot it, we can plot x versus y with some markers, and we can plot xp, yp right over it. If we run this, it'll ask to save. We can call it curve fit example. And we should get a nice pretty plot that looks something like this. Now what I can do is I'll put this over to the side, and let's change the n value one at a time. Instead of n equals 1, we're going to change it to n equals 2. Let's see how the plot changes. Now we have a curved line. If we go to 3, changes a little bit more. Let's go to 5. Changes even more. And if you remember, the maximum that you should go with your nth order is going to be the number of data points that you have minus 1. So there were 8 data points, so the maximum that we should have is 7. And let's see what happens when we use 7. You can see the data starts to get kind of funky, right? So just because we can use 7 data points doesn't mean that we should. But you will notice that if we use the maximum value, in this case is 7, the line that gets generated goes through every single data point exactly. If we try using a different value, anything less than that, you'll see that it partially goes through some of them, but doesn't typically touch them exactly.